Now, half the time when I go and track down the person who's got it and say, oh, I need to edit this file, they say, oh, I'm not even working on it. So, you know, it's good to try and avoid the exclusive locking when we can. Another thing is, when you have files in some kind of binary format, so you say, oh, we'll do our architecture document in Word, okay? When you do that, you actually throw away the information that your version control system can give you about exactly what got changed. It's much, much better to work in some kind of plain text format. And it's not like there's a shortage of things that are very easy to read and work with in plain text, things like Markdown or POD, which can then be transformed into HTML or PDFs or anything like that. So it's not saying you can't get some nice sort of output format of it that you can pass off to someone who is sort of scared of a little bit of markup, but it means that you can work in something that's really nice in version control. Too many version control systems make branching kind of a painful thing. Now, the problem is never making the branch. The problem is always when you come to merge the branch. I don't know of any version control system where, you know, making a branch isn't one command. But when you come to sort of join the branch back into your sort of master or trunk or main development branch, that's when the headaches arrive. And you know, this can be a real pain point. And I think part of the problem is that a lot of the version control systems that we've been working with of late have actually made branching sort of a big deal. Branches are one of those things you don't just create on a whim, because you know you're going to have to do that whole merging thing later on. One of the trends that's really nice in the version control world is that people are looking more and more towards what we call distributed version control systems. The idea of distributed version control systems is that essentially everybody has a copy of the repository. And you maybe have some sort of shared version that everyone pushes their common changes to, but essentially because it's a distributed model, you're always doing merges, so they have to be really, really good at it. They tend to track changes rather than whole revisions. They also have a full set of the history available locally. So if you want to dig into your version control and sort of look through the history, you don't have to go off to some server and actually wait for it to come back and give you an answer. You have it all right there. And if your thought is, oh, that must mean that my initial checkout is really big, or it must take absolutely loads of disk space, you'll probably be surprised to know that the typical checkout with a distributed version control system like Git or Mercurial is actually faster than checking out a single revision with Subversion a lot of the time. This is kind of incredible. It's actually tied into this, the fact that they're tracking the changes in a very different way. So the other thing is that if you've got a complete repository locally and you can do all the operations locally and just share the stuff later, you can actually commit when you're not connected to the net. You can hack on code anywhere. You can drag your laptop up a mountain with you, sit on top, enjoy the view, write some code, be doing your small regular commits, so you get the nice version history, then go back down the mountain and sort of plug in and push the stuff off to the net. Now, I'd really like to just give you a little demo of distributed version control. Now, I'm going to show you Git. I'd like to just add before I do this that this is just one option. There's a bunch of others out there, and there's one called Mercurial, which is also very good, and actually a lot of the concepts are really similar. I'm also going to show you this at the command line. I will add as well, there's a bunch of GUI tools if you're not a command line person. I am, and pretty much every version control system, regardless of what toolchain it has in the GUI, I probably still reach to the command line. So it's sort of a personal preference thing. It's getting cold. That's not nice when coffee gets cold. Okay, so what I am going to do is I actually work on some sort of compiler and runtime stuff, and I've decided today that I want to just implement a small feature, and this feature happens to be called duck tables. Which is a really funny name, but it's related to vtables and duck typing and stuff like that. So I decided that I'm going to work in a little branch for this, just because it makes my life easier. Now, I'm not connected to the net at the moment, so every single thing I'm going to do here is actually a disconnected offline operation. So the first thing I want to do is make a branch. So I'll just say git branch, and I'll type the name of the branch that I want to create. So I'm just going to do that. Now, at the moment, if I just show my branch list, then it tells me I'm in the master branch. This is the analogy of trunk that you would have in Subversion. It's worth mentioning it's just a convention in Git that you have a master branch. So then I can actually switch over. I can just say checkout, and I can go over to that branch. Now, checkouts are actually in place with Git. So it's not like Subversion where you have a different folder for every branch. Okay, this is just an in-place change. So what I'm going to do is, okay, the first thing I figure I'm going to do is add a little bit of documentation. So I'll just open the world's best text editor, Notepad, and I'm just going to put some really informative documentation in here. Okay. And there we go. So I've added a new file. I'm going to add it to my version control. Remember, I'm working on my branch. So I'll add that file. And I'm just going to commit okay. And it's gone and committed that change. So it's time to open Visual Studio and go and start doing some work on the code. So let's do that. Let's open up .NET runtime and pull up this. Now, oh noes. So at this point I realized that I had my solution in Visual Studio 2008 and it wants to convert it. Now I've got a bit of a problem here because what I think is, well, yes, I want to do this conversion, but it doesn't belong in my branch. Now remember that branches are just sort of an in-place thing. So I can go back over to here and I can just say, oh, well actually, I'm just going to go back to the master branch and do this change there. So I run the wizard. Let's just click finish. And it goes and updates my project file. Okay. And if I go and look at what's changed, then, okay, like demos. So we can see that it's gone and just changed the project file version. So what I'm going to do is I'm just going to commit this change. Okay, that's in the .NET part of the project. So I've done that. And okay, now it's time to go and continue with the bit of work I was doing. So we go and check out my branch. And you can maybe imagine what's going to happen here when I flip back to Visual Studio. Okay, who's seen this one coming? So what it said to me is, hey, hang on a second. Actually, you switch back to the branch, so you've got the old version of the project file. Well, the trouble is that they actually made my branch after, before I went and did that change. So on the one hand, they could sort of go and throw away my branch and start again. But in a sense, if you imagine history as sort of a graph, and we sort of had a master branch, and then our graph sort of forked into two bits. We sort of had a DuckTables branch here, and our master one is sort of a commit ahead. And it would be really nice as if I could just pretend that this path forked after the change I did in the master branch. Well, we can do that. It's called Rebase, and all it does is just shuffle along where the path forked pointer, and it's actually quite clever because it undoes the commit that I did. It applies the latest changes from master, and then it reruns all of my commits in the branch on top of it. So that was pretty neat. So let's go and actually do some work. So if I just flip back over here, okay, I can reload this now, and it's happy. So let's go and find the file I want to change. It's in here. So I go and find the appropriate point in this file to go and stick my change. And okay, it can probably go beneath this, and it can be okay. So I'll just add some data structure. Now I'm sort of halfway through my change here, and I want to do a bit more, but suddenly I noticed something. I noticed that actually I don't actually need to have a long here. I just really want to have an end. And I really want to fix this before I go ahead and finish up my other work. The trouble is that I've just already started it and saved the file. Wouldn't it be nice if I could just hide away the change I've already done and say, oh, I'll come back to it later? Well, I can. It's called stash. And it's just like pushing the current change set onto a little stack. So if I go back to the file here, if I reload it, my change is gone. Okay. So now I'll do the sort of actual change I wanted. I'll go and make these ints. So if I diff now, we can see that I've just changed those two. So what I'll do is I'll just commit that change. Okay. So now I've got my file with that change in, but I want my work back that I was doing earlier. Well, all we do is we just say git stash apply. Okay, and you'll see it says it's auto-merged because it was in the same file. And if I flip back to this file, we'll see that it's got my change there, but it's also got my bit of work that I had earlier. So I'm just going to finish this up. Right. Okay, and save it. We'll go and commit that bit of work. Let me just make sure the folks at the back can see. Okay. So implement duck tables. What do you like? Oh! Duck! So this is really bad because when I commit this and push it off to everyone to see, what are my co-workers going to think? They're going to laugh at me for weeks, okay? I can't believe I made this duck up. But what I can do is I can actually, because this is all local, I can actually go and just say, oh, I'd like to amend the last commit. So I can fix this, okay? So what I've done now is I've just gone and said, instead of making a new commit, take what I did last time and just do this instead. And if I'd actually made a mess in a file and suddenly realized, you know when you commit something and you hit enter and then you're like, oh, this is embarrassing, okay? You can go back and do the change in the file as well, do the amended commit, and it's as if you never did anything. If I go and look at this, okay, this is my history tree, you'll see that my lookup is not in there. So, we're happy, and our history is looking good. So now it's time to merge our branch, the scary part. So I'll go back to master. Okay, and all I'm going to do is say git merge the tables, and it shows me which files it's just merged in, and we're done. It's really good at merging. They use this for the Linux kernel, and they have stories of having 12 different sort of branches that they wanted to merge into one, and it just handled it. It's pretty good stuff. So that's Git. So who likes the look of that? Yeah, it's nice. So there's a bunch of GUI tools. The one to look at probably is Git extensions. If you have used Tortoise SVN, I'll warn you up front. Tortoise Git is, from what I've heard from friends, not that great. Apparently they've sort of tried to shoehorn the Subversion model into, the Git model into the Subversion one, and they're actually quite different. If anything, I guess the challenge of learning Git and Mercurial and so forth, it's in part forgetting what you know about Subversion and sort of the assumptions that you make about version control. So I'd like to move on and just talk about automated build processes. So wouldn't it be nice if we can take the stuff that's in our version control, just click once, or maybe even trigger it automatically, and magically we get out the bottom of this a full build of our product, and maybe even a deployment of it. How many of you can actually do that? Okay, a few hands. So how many of you can then actually go and do the deployment? Not just the build, but the deployment as well. Okay. Okay. How many of you can say that everyone on your team can actually produce a build? So the thing about